This conference will now be recorded.
I'm choosing one of the action. Action number 5. Maybe next time answer might be different. You got the points. Here now, actual your Q learning formula is here. What is the mathematics behind all these things? I will explain the mathematics of Q learning in a separate class. That means in tomorrow class I will explain. For now, how you have to try that process you try to understand. So line by line I will explain in tomorrow class what exactly each line is doing, how exactly this mathematics of Q learning equation will work. We will discuss completely. We dedicate tomorrow class only for this function. Okay. So now I'm initiating a function for updating of Q values. Already have seen Q values in the beginning. What are current Q values? 0. Okay. For every iteration of training, the Q matrix will be keep updating. In what way this will be updated? Always to achieve max rewards. Understood? So forget about mathematics of this Q learning for now. Tomorrow you will get it. I'm initiating this. Max index is that here. One more. Q learning. Okay. Something is burning. Max index equal to condition ready. Max index shape is greater than 1. Okay. So this function is not returning any values. Simply it is trying to update always the matrix of Q. That is what they were last at. So for this updation, then what exactly you are seeing in this part? This is what the Q learning formula. Understood? So forget about the mathematics of it now. Your update function is ready now. Then what is pending? You just imagine. Till now your R matrix ready. That means environment. Q matrix ready without knowledge. That means with initiating with 0 values. And the third step we have initiated a gamma value. And fourth step, you define a function. What are all the to find what are all the possible actions from a particular current state. And the fifth step, from the possible actions to select one of the next action. These are the steps. And the sixth step is to update your Q matrix. One last step is pending, training. Till now, what are all the weapons required to train agent? These weapons are ready, but training not yet completed. The training part will be here. These are the 4 steps. How many iterations you are running? Range 10,000 means what, sir? 0 to 9,999. Starting from 0. That is totally 10,000. But how many iterations that you need to select? That discussion. Please wait till I explain the mathematics of it. Once the QA learning mathematics part completed, I explain you how many iterations that you need to select. So for now, I'm initiating 10,000 iterations. Here observe, only the training has only these 4 steps. Try to understand what is the meaning of it. Previously, we did some max fixing as initial state number 1. But here, in the first iteration, it may take initial state as 0. In the second iteration, it may take initial state as number 5. In the third iteration, it may take initial state as number 2. For that, randomly, one value has to be selected as initial. Understood this? From that initial state, what are all the possible actions? Already we have function for it. Understood? But possible actions are multiple. To choose only one action, the next function. After that, based on the action it has performed, based on the reward it received, the knowledge matrix has to be updated. For that, update function. These are the only 4 steps to train your agent. Got the point, sir? First step, keeping agent in some of the random initial state. Step 2, from that state, what are all the possible actions that agent can perform? Step 3, from the multiple possible actions, select one next action. When our action performed, current state will be changed or not? Current state will be changed. At the same time, receives a reward. Based on the reward received, updation of knowledge. Because your update function is targeting what? Your update function is targeting what? Q. In the beginning, Q value is zeros. Now Q values will start updating. Understood all of you? Now I'm going to train, sir. Before training, once again check the values of Q. Print Q. This is before training. Now I'm going to give training to my agent. Training started. Print Q. What happened? Before training, after training, what is the difference? Previously, no knowledge. Now, knowledge. What is the max value here? 500. Even if you go for 20,000 iterations also, the count won't be increased. Because how much max possible learning is there, that much max possible learning it has done now. Understand the point, sir? But there is a question. A student 1 and student 2. I am giving you scores of 2 students in the mathematics subject. First student got 29 marks. Second student got 99 marks. Who is intelligent? Okay, in this, who is talented in this context? You cannot say. You cannot say. Because student 1 got 29 out of 30 marks. Student 2 got 99 out of 300 marks. Now tell me who is talented. Understood the point, sir? Just by seeing the score, you cannot say. Because in this context, in this example, here the max score is 500. In another environment, the max score can be 1000. Maybe in another environment, the max possible score might be even 1900. But whenever I adjusted all these values, to the max of 100, I can say easily. That's why a small game here, a small change here, Q divided by 100. Q divided by Q dot max. What is the max value of this Q? After training, 500. If I divide all the values of its max value, what will be the max value now? 1. If I multiply this with 100, All scores will be maximized up to 100 only, right? Now easily you can understand the environment. That is what. Now what is the max score now? Now you don't find any difference. Student 1 from Nagarjuna University, student 2 from Usman University, like that. You can easily compare that. Understood the loss technique, sir? What we applied is. So these are the values of your Q. Of course, directly you can proceed with this, but for your understanding, you are adjusting the values max to 100. This is what this technique. Come on, sir. Now I think 7 steps completed. Please recall them. Step 1, environment. Step 2, knowledge with zeros. Step 3, but one caution. Environment size, knowledge size should be same. Understand the points? Third step, gamma. That means learning parameter. We need long-term reward. Understood? That's why close to the value close to 1. But it should not be 1. It should not be 0. Between 0 to 1. Fourth step, identify next possible actions. A function to identify next possible actions. Number 5, from the next possible actions, select one next action. Step 6, function for updating. Updating of the what? Yes, knowledge matrix. Updation of knowledge matrix. So within this updation, actually the Q learning equation will come into the picture. Your agent needs brain, right? The brain is Q learning equation. So in tomorrow class we discuss about that mathematics. Next, finally, updation is ready. Then train the agent. Training completed. Then after training, what change you observe? There is a knowledge. Next step, how to make agent that it can use this knowledge. Did you understand the last step, which is 8th step? Got the point, sir? For this, the related code you just observed. In another separate class, how your agent is going to use this knowledge matrix. After tomorrow class, I will explain this one complete. Another 2 sessions we are going to take on this same game. Observe this code. Initially, you are keeping your agent in number 1. Understood this point? Just for output. What path it has selected? The root path. Just you are printing those values. Now you tell me, sir. I believe and I hope all of you people have the picture of our game in your minds. Come on, sir. I am keeping you. Now you are agent. You are a trained agent now. Before you are not trained agent. Now you are trained agent. Already have knowledge now. Now I am keeping you number 1. Which is the best path? You tell me. 1 to 5 is immediate gunshot, right? Come on, check it. Here equal to line mistake. Where is that? Still anywhere? This one, right? I'm keeping in number 1. What path it has selected? Directly 1 to 5 without second part. How it's selected we will discuss. Come on, sir. I'm keeping in 0. What is the right path now? First you tell me what are all the possible paths. 0, 4, 5. 0, 4, 3, 1, 5. Okay, which is best? We need optimized. 0, 4, 5. Come on, check it now. Understand? Your agent is behaving very smart or not? Come on, sir. Again, test it with number 2. Which is best? Keeping, listen. You have 2 ways now. 2, 3, 1, 5. 2, 3, 4, 5. Cost same or different? Cost is same. So anyone it will choose it. Anyone it will choose it. 2, 3, 4, 5. Maybe in the next time it may choose 2, 3, 1, 5. If 2 different ways, that means this is called a policy. What are the key terms of the reinforcement learning? Environment, agent, knowledge, the brain, Q learning. Finally, after training, finally it will achieve what? Best policy. If 2 policies having same cost, at the time agent will choose any one policy randomly. Understood the point? Okay. Keeping into 3, tell me the ways. 3, 1, 5. 3, 4, 5. Anyone is okay for you, right? Correct? Keeping into 4. Keeping into 4. What is the path? Best path. 4, 5, that's it. Got it? Keeping into number 5. Already you are in 5. Your goal state is still 5. So that what is expected? You have to stay in 5 only. It did not go anywhere. Still it is there in the 5 only. Did you understand or not? So how exactly this logic works, each statement I will explain after completion of the Q learning equation mathematics. Okay. Tomorrow we completely dedicate for Q learning mathematics and how exactly your update function is working. On the next class, we will see how your agent is going to take help of the knowledge matrix and takes the decisions. Got it. Just keep observe what exactly happened here. Look at this value. I am keeping in 0. 0 means this is 0 state. What is the max value? 80. 80 for which action? 4. If you are in 0, directly it will jump into number 4. After performing the action number 4, your current state will be changing or not? Now your current state is number 4. Now here, what are all the non-zero values? 64, 64, 100. What is the max value? 100. 100 is for action number 5. Immediately it will jump into number 5. Understood? Come on, sir. I am keeping in the rule number 1. Tell me. 2 non-zeros are here. Think that these are not rewards. These are knowledge scores. Understand the point, sir? There are 2 non-zeros, 64 and 100. Max value is 100. 100 is for number 5. That's why if I keep you into number 1, directly will jump into number 5 without any second thought. Sir, first time you came to Amirpet, sir, I am asking you go to SR Nagar. There are 4 or 5 possible ways. Initially, you have a thought in which way is best, in which way is best. After you perform the same action repeatedly for 2 times or 3 times, you will find which is the best action. Next onwards, if I ask you to go to that place, directly will choose optimized path. Like that, your agent is behaving. This is what the difference between before training of agent, after training of agent. All of you understood this one, sir? Okay. So this entire code, after completion of my remaining 2 classes of explanation, you just take it. For now, just to summarize the steps of training agent, sir. Tell me the steps. Total 8 steps. We got it. What is step 1? Environment. Step 2. Simply say Q matrix. Our algorithm is trying to update this Q. That's why this is called Q learning equation. Understood the points? Later we will understand how to integrate this Q learning equation with the deep learning. That is called deep QRL. Exactly in 2020 that is demanded. RL outdated. Okay. Next step is deep QRL. Not only deep QRL. Nowadays new concept. Double deep QRL. Double Q learning. Again, double Q learning, if you embed into the deep learning, that is called double Q, double deep QRL. Understood? But for all the things, the basic step is this one. If you understand really this one, easily remaining things you can easily understand. Step 2 ready. Step 3, my gamma. That means learning parameter. Step 4, find available next. Available next possible actions. Next step 5. One. Next action, not now, current action. Okay. 6. Update Q. Update Q. So here exactly the Q learning equation. The algorithm actually here. Right? Step 7. Fine of what? What is agent here? Where is agent here? In this entire program, where is agent? Your entire program is called agent. Did you remember in the beginning class I told you? Agent is a intelligent program. Understand the point, sir? Suppose the driverless car. In the driverless car, who is agent? Car itself is agent. Understand the points? Like that. Here, if you treat this entire program as application, your application is agent. Got it? My last step. Use what queue? Find queue. And take decisions to perform actions. 1 minute. Understood this? These are the 8 steps you need to remember. Okay, sir. Step 8 simply what we did is testing. In the step 8, we tested our agent behavior. How you tested? Manually or automatically? Manually. Later in the ending, you will learn how to do the testing process of agent automatically, in the automated way. Now you are testing manually. First you are keeping wantedly, you are keeping into 0, wantedly you are keeping into 1. On that way you are testing. But how to make it automated? In the climax you will get to know. Okay, satisfied about this testing. What's next step? What next step? Deployment. What should I deploy in my production? What should I deploy? Only knowledge with environment. Knowledge with environment. Understand the points? So you have to deploy your agent, that means your application, along with environment and trained queue, not before trained. Trained queue you need to deploy. Think that if you treat that game as a traffic rule system, that to Hyderabad traffic rule system. Sir, if it is traffic, is there chance of rules changing? Maybe last month some rule, this month some rule may be additionally added, some rule might be, some old rule might be deleted. For example, helmet carry, sir. Helmet on the bike is mandatory or not? Presently in Hyderabad, the second person need not to carry the helmet. Maybe today or tomorrow, department may launch that rule also. Whenever they change that rule, environment has to be modified or not? Whenever your business rule changed, your environment has to be changed. If environment changed, can you use the same trained queue? And at the time, what you have to do? Again, you have to rebuild the model. That means rebuild the agent. That means reinitiating the process of training. Once the training part completed, you can direct straight away, you can deploy. Understood? But when retraining is required is when it is required. If any environmental rule changed, again you have to retrain your agent. Understood? But for some business applications, the frequency of rule changing is very less, or the interval might be very long. Suppose, especially if it is a traffic system, maybe for every 6 months or 3 months, the rules will be changed. Understood? But if it is our class course room content, understood? For every 10 days, the course content will be changing. Daily new algorithms are coming. We need to add into our content. At that time, very frequently, maybe weekly once, you need to retrain the user. Did you understand my point? Okay. Right, sir. So for now, take these step 1 to step 8, these 5 steps, summary. Once I explained the Q learning, you take that update function. Come on, now we take. So online team, please take these 8 steps. Okay, all of you completed. So next 2 classes we complete the remaining part of explanation. Today by afternoon I will upload into the YouTube channels. Once again go through that video. Okay, let's meet tomorrow, sir, all of you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Sir, can you please show the def update?
Tomorrow, not now. This is just a demonstration of Vinay.
Okay, sir.
Tomorrow,
Thank you, sir.
once I explain Bellman equation, each line what it is doing, we will be discussing. Okay.
Okay, sir. Thank you, sir.
Sir, is there any other class today? Statistics?
Yes, Gangadhar, you want to say something?
No, is there any other class today, sir? Or
No, today no classes.
okay,
Tomorrow I
thank
will
you,
add
sir.
the stat class also after completion of
Okay,
this reinforcement learning. For today, this is the last class.
thank you, sir.